you've got a lot of carbon-13 all over the place. And nothing to measure. So that for an organic chemist doing NMR spectroscopy, carbon-13 is just as good as carbon-12 for NMR, except for a sensitivity problem, because you've only got 1% of carbon-13. But it's perfectly doable. And the others are, that are commonly studied are F19 and P31 and N15. P31 and N15, of course, will be important to the biochemists. Because phosphorus and, of course, nitrogen are a big part of nucleic acids and proteins, etc. But we're just going to talk about what we call proton and carbon NMR, or C13 NMR. Proton is what NMR spectroscopists call H1, because what we're really doing is studying the nucleus of that hydrogen, which is in fact a proton. So don't confuse the acid proton with what the NMR person means when he or she says proton. Proton in NMR means H1. What you're going to get in a, let's say it's HNMR, you're going to get what we call a spectrum that contains data. And you're going to look at the data in terms of peaks. There's a baseline that runs horizontally and peaks that rise off the baseline. So those of you who are taking organic lab, it looks sort of like a chromatogram, but with a different scale. These peaks refer to the chemically different hydrogens or hydrogen types in the molecule. So if you see 3 peaks, the number of peaks tells you the number of chemically different types of hydrogens. Where these peaks are on this axis, it's actually what's called a part per million scale, will tell you what those types are. So like that molecule, the alcohol we were looking at before, there were 3 types, and this is going to tell me where the peaks are, it's going to tell me what kinds of hydrogens those are, and the areas underneath the peaks going to tell me the relative numbers of hydrogens of each type. So the number of peaks tells you the number of chemically different types of hydrogens. Where those peaks are tells you what those chemical types actually are. And then the area underneath the peak will give you an indication of how many hydrogens of that type